So, namaste, good morning, good afternoon, and good evening, depending on what time zone you are in. And welcome to the talk about what's latest and greatest in Java. And that has happened in the last 1 year. When I say 1 year, it's around 2021, the March 2021, which is the 16 release, and September 2021, it's just a few weeks back. That's a Java 17 release. And we'll talk about a little bit about what is going to happen in the future, the near future, that's in March 2022. So some of the work will be done in this year. So we'll touch upon that as well. Uh, oh, I think the slides has gone a little beyond. Now, all of you know that there are there is Java C that is given by Oracle. Similarly, if you are from the Eclipse side, Eclipse world, you would know that Eclipse has its own Java compiler, our own compiler called Eclipse compiler for Java, and that's what I work on. I'm Manoj. I work in IBM. I'm in a open source lead and committer. I lead the Eclipse compiler effort. Also, I represent Eclipse Foundation and the EG group for Java language in the last few releases. So, but whatever we are speaking here applies to Java in general. All the very nuances of compilers differ. So if we are talking about specific error, it is be about the Eclipse Java compiler, not the Oracle Java compiler. Anyway, suffice to say that primary focus nowadays is to get these features out because we have a 6-month release cadence for Java. Now let's get into the latest and greatest of Java language features. See, Java has a lot of features, but we'll be speaking about the language features, and I'll be speaking about some of the select language features. These are kind of can be classified into one bucket about the Java language changes itself. From 16 point of view, we had oh, two features. One is records, and one is pattern matching instance of, and these have become standard features. And the 17 point of view, we have the seal types, which is a standard feature. But we also have the pattern matching for switch, which is the preview feature. So if you're not familiar with the standard and preview feature, Java with the six-month release cadence, it has come up with this idea of a preview feature where the feature becomes preview on the first releases, and then it would go into the standard feature at a later point of time after taking feedback from the users. Now, instead of going through all these features, let us, in this talk, let us take a look at some of the motivation for this. Why such? Why these features are there in the first place? Let's start with something called ad hoc polymorphism. This jargon is a little fancy, but this is something most of us would have used at some point of or the other. The example above, in the example above, we are handed over an object, and depending on the type of the object, we do different things. Essentially, we kind of, if you look at this, there is an object obj, and inside the method foo, we check whether it's an instance of int, instance of neg, mul, etc., and then do different things. Essentially, we calculate the value of int, neg, or say multiply by left and right, depending if it's an mul, etc., and return the result. This is a classic example of an ad hoc polymorphism. There is no specific supertype other than the object, of course. So, what is the what is the problem here? The problem here is we would have to look at the type and use programmatically. You have to check what kind of type it is, and then take a decision of decision of which control flow it has to take. There could be a slight improvement, of course, with our with the pattern instance of which you should be familiar with. Here, the only thing is there is a int, and there is a variable associated with it, and you can directly use that myint without typecasting. Now, this might look a little easy from the programmer point of view, but there are a lot of things going on inside the compiler. There are a lot of scoping rules. But however, from a perspective of dynamic type checking, it's still you need to explicitly do the type check. And you know that this feature is available from Java 16 onwards. So what is the problem here? It's a explicit type testing. And what is the immediate solution? That is something which all of us know, That is the uh, first step is to create a hierarchy. Now, once we have a hierarchy, and how do you create an hierarchy? We would look at the we would create an interface and we would have a nodes, implement those nodes, and instead of object we have a node as a hierarchy. It's not a hierarchy in terms of class, but in terms of something which you can use. Say in the API you just have to give node instead of specific in node or node, etc. And the advantage comes when you have a eval function which returns a value of it. For int it returns int, for neg it returns minus that value, and mul node it just multiplies and gives you the result. So the foo now gets replaced. So what we have done is the foo now degenerates into just a instance of call of node and then returning a eval, and the eval would take uh, will take the trouble of dispatching to the correct node, and it will return the value. Now, analyzing this approach, we would say that this works well for operations such as eval, which is kind of intrinsic. You know, if there is a in node or mul node, there is some value it has to return, and eval is a way by which you evaluate that nodes, and then you return a result. But let's consider some of the cases where there are very specific to some of the nodes. Say, one typical example is return the node value if the left one is less than 10. Now that might apply to mul node and add node, but it may not apply to in node or neg node because there is no left or right here. And the point here is these are not intrinsic, they're very specific, and in such cases the API will become very hard to maintain, and it's really not the right good design. So the real problem here is we are kind of coupling the hierarchy with the operations. So the way forward is to bring in the visitor patterns and take this tight coupling of the hierarchy and the operations separately. And this is something which you must be very familiar with. It's a visitor pattern. Essentially, you have a node and you traverse through different nodes with different operations. And from the see, if you have an interface node visitor that takes each node in node, neg node, etc., and then you define a visitor node which goes through each of these nodes, and each of these nodes will have an accept method which takes in the visitor node. If you look at our compiler code, you can see that the compiler code consists of taking a source code and giving it to a structure. And when you give it a structure, the first thing you give it is an AST. And this AST, that is abstract syntax tree, consists of different nodes, be it the compilation unit, be the statements or methods or fields, etc. Each of them is a node, and even the statement itself can have if statement, while statement, etc. So as a whole, it looks like the entire tree as a tree of different nodes. And the visitor pattern, in fact, very nicely fits into this, where you can go into each of these nodes and apply the appropriate method. And why is it important? Because you would have to traverse this node at different points doing different things. For example, you might want to do a code generation. And for that, you apply a particular function. You might want to do just a printing out of the method. There again, you do a different thing. So this visitor pattern helps in applying these functions at each of these nodes. And thus, this gives a this the idea this implements this idea very successfully. Separates the operations from the hierarchy definition itself. But what is the problem here? One problem is every node will have to have an accept method, and again it becomes slightly verbose, sometimes really verbose. When you have to do a visitor method, there should be a and it gets more and more complicated if there are multiple levels of visitors involved in a single traversal. So what do we do? So this is one motivation for us to get into, and of course it's not sort of for arbitrary visiting things. So the solution here is to bring some deconstruction here. So let's see what is deconstruction. Call it deconstruction patterns. No, a word of caution here. This is where we want to be. The Java is not yet there. So if you look at the right side, you can see that this is like you are sending a node n, and there is a switch n, and the switch is switching based on the type rather than the value. It switches based on node and selects one of these cases based on whether it's an in node, neg node, add node, or mul node. So deconstruction pattern is like a construction in reverse. It's like if we can have access to all the state components which we pass to a constructor and then use that and make it kind of reversible and extract that. So consider the case of in node where you are having this node, in node and int I, and then you're extracting that parameter I. Please be aware again that we are not yet there, but let us see what are the building blocks and see where we are in terms of this. To have this deconstruction building patterns, the first and foremost, it will be nice to have a constant data carrier classes with accessors. That is, these can be represented by a constant class where we get some accessors through it. That is, we can pick up a I if you want. Then if you are able to make sure that the compile time we are able to see what the hierarchy is, the switch expression becomes pretty easy and in terms of error checking. And of course, the switch, the third one, the switch has to the switch has to be enhanced to allow this kind of type checking, this kind of type based switch. And lastly, the extraction syntax and semantics of what you're seeing here. Taking a look at the first building block, the constant data carrier with accessors, you can see that the records feature provides this. If you have a class called entry, it has different fields. For example, all the two fields, let's say name and age, they are all private fields. And we are defining a constant class primarily because we want it to be a carrier class, data carrier class, and we have just two fields which are final. Then you will have to define this constructor. We'll have to define two accessors for this name, age, etc. And along with that, you would have to take up the default int hash code and equals, which of course come together, and then the toString to print out. Now, all these things can be just pushed down together to one single thing called record, which is a new restricted identifier. I would say it's not exactly a keyword that can be used to encapsulate this whole idea. And internally, of course, the compiler would generate bytecode into a class with just a flag. It's not a flag; it's a field which says this is a record. That's how we get the first building block. That's a constant data carrier class. Now, second one about hierarchy-aware compilation. So we see that in the switch, there is a node, and this expression of the switch, we should evaluate exactly only one arm. It also means that there should be at least one arm that applies to any input. Otherwise, the value of switch expression might be undefined. So if the switch has a default arm, then there is no problem because it will get into the default arm if it doesn't match any of these. However, if we write the default clause, we lose the ability to have the compiler verify we have exhaustively uh, enumerated the cases. When you talk about enumeration, of course, the enum comes into picture where you have the option for enums. If the switch expression has all the enums, then you don't have the default clause even now. Now, the same concept is applied here into types, where if you're able to know what are the types at the compile time, you can then you don't have to use the default, and the compiler error checking is much better. And this is what is provided by the sealing the node. And this is a syntax here. You put a restricted identifier seal, then interface, and then node, and then you say permits. This color has to be different, but let's say just assume that it's a restricted keyword. It is indeed, and then you say it this particular node permits in node, next node, mul node, and add node. Just four nodes, and all these four nodes, each of these four nodes will have the final. Need not be final, can be sealed, but at this point, for simplicity's sake, I put it as final. So at any point in time, you know that when you are switching on node, it can contain only these four values and nothing else. Sealing is kind of a generalization of the finality. When you put a final, it means that nothing can extend. And if it is non-final, that is absence of final means anyone can extend. Sealing is kind of a middle path which says only these many things, which it permits only those things. Those classes can extend the type. So now let's see how does the records and seal types clump together before we get into the third one. If you put records and seal classes together, you can see that the records, you can see that the this idea fits nicely into the pattern switches because it uses the concept of constant case labels, and this constant comes in terms of records because they are data carrier classes and helps in the exhaustive analysis. And briefly digressing into something called algebraic data types. In fact, uh, I'm sure there are a lot of mathematicians here, but some of you would recognize that this is what is called the algebraic data type, where the record provides uh, a record and seal together provides the product and sum. When we say algebraic data, it's some kind of a composite type where it is formed by combining other types. And two common types, one is the product type, which are tuples, and other one is the sum type, which is like disjoint union of the sets. And of course, you know that there are operations like introduction and elimination of the types. They are provided by construction with the params, and elimination of usage or usage of this type is by accessors. And similarly, the sum is provided by the hierarchy, and you can use it by pattern matching or visitor or case statement, etc. For completeness sake, the exponentials is given by lambda, which is already covered by Java much long ago. Okay, now pattern matching in switch. So what does it provide? This provides the third and fourth part of it. In fact, fourth part partially, but let's see what it is. It's an enhanced switch statement uh, because it takes in a node and it switches on a type of the node rather than the value of the node. So you have node and it switches on in depending on in node, neg node, or mul node. It gets into the right side and it extracts a value I dot value and does things with that. And in conjunction with that is the sealed interface node, and it provides all these records, and this provides exhaustiveness, so you don't really require the default case here. And this is the extraction semantics what we talked about at this particular point. However, if you remember the earlier slide, we know that the the thing what we had in mind was a little different. It had a little more complicated stuff in terms of add node and mul node, etc. At this point at Java 17, with the preview enabled, what we have is the first level of extract syntax, similar to the pattern instance of we have in the node I, where the type is extracted into I. So I would term this as a first level since we recognize only one particular variable here. So the missing step is to to having a construct system. This is what is expected to provided by record and array patterns in the near future. The if this was these extractions, that is the composite extractions, this would be provided by the records and array patterns, which was supposed to be coming in 17 release as a preview, but it has got pushed down. So I think it would come in 18, but the JEPs are all still in the discussion phase. So we'll have to wait and see. However, it's expected to come soon. Okay, now. Okay, so what we are talking about is this extraction, the first level of extraction, while the second level of extraction is this in node int I. So much for the discussion of the features. Now let's get into a little bit of nuances of switch. See, if the switch allows a selector expression of any type, the case labels can have type patterns. Then the standalone null test also is like a distinction because the type can become null. So there is a provision for having a case null, which is something introduced uh, in 17. And again, this is the how the null is interpreted on when the switch is type when it's switching on type is kind of fluid at this point. At this point, if there is a concept of totality of types, so even the null is considered as part of the type, and uh, that particular case is accepted. So going a little further, the case statements are not exactly disjointed many times. For example, in this case, you can see that there is we are switching on an object, say assumes that O is an object, and then we have something called a guarded pattern. We can say whether if the object is a list L, and the length of the list is greater than 2, then you do something. If it is on the, if it's just a list, do something else. See, a point here to be noted here, noted is that the first one is more specific and second one is more generic. So uh, it's always a list. So if you put list first and then the second one the next, then this is kind of an error. Only the first one will work because the more special case should come first and then the generic case, because only then the switch would know which one to take. So internally what happens is when you're switching on it, first it'll go from top to bottom, and depending on whether we hit upon the case or not, it'll go back, calculate, and then jump back. So it's one flow in one direction. And so there is a question, there is a idea of a dominance here, or in layman terms, you should put the specific case first and the general case second. For example, you should put if there is an integer and object, you should put integer first, case integer I, and then case object O. Kind of pretty common out here. So with that, I come to the end of the slide. But before closing down, let me say that if you are interested in to know further about this, look at the JEP 406, the pattern matching in switches. And if you're interested in the algebraic data types, there are for types in programming languages by Benjamin Pierce, take a look at chapter 11, and even the lectures by Batros Milewski. They're also pretty good to talk about the algebraic data types, the theoretical part of it, in a very simple way. And of course, you have the Java language and Java JVM language specification. Uh, this you can use as references. In addition, you can look at the wiki.eclipse.org Java 17 examples, and there we have listed both the let's say going back to that, we have listed both the positive cases as well as negative cases. So the positive cases will tell you about the feature, and the negative cases will give you glimpses of what works and why it doesn't work. So I strongly suggest you pick up those as well. And uh, with that, I'd like to thank you for attending this talk. I think I guess just one more minute. So let me just click on this Java 17 examples and see whether I'm sure you should be. I hope you are able to see this code. So here, this is the wiki uh, Eclipse Java 17 examples, and here you can see the different features, the pattern matching switches, the positive compilation. And if you go down, let me pick up. So here you have the negative compilation, where you say that you cannot have more than one pattern case label element. So there are a lot of rules associated with it. And this is a classic case, for example, where you have a primitive and then you're trying to fit a type into this. So these are the things which the compiler would not know which one to pick up. And of course, yeah, one particular feature I missed out is the case default. Like case null, we have something called case default, but the meaning is the same. So you just cannot have two, the case default as well as the default together. Yeah, so there are a lot of things, and I think I'll close on to this. Thank you. Uh, guys, after the presentation, I realized that we have the JEP 420, which is the second preview that is coming in Java 18. So 406 was the preview one, and 420 is the next one that's going to come. And if you want further information, there is an expanded version of this in the blog which I have written. It's called Brewing Patterns in Java, an informal primer. You're also welcome to have a look at it. Yeah, so one question I have is, does the sealed force implementing classes to be final? What happens when I try and extend the class implementing the sealed interface? Well, I think it's asked by Vincent. So the answer is, it doesn't force you to implement to be final, but it, of course, either it has to be final or a sealed class or a non-sealed class. So you are supposed to give a modifier out there, and at some point you will have to end it, and at that point there will be a final. A similar case, it's nothing different when you try and extend a class implementing a sealed interface. The point here is, at the time of compilation, it should be a complete interface. And I see there is one more question as to which Jay has answered. That's whether are any plans to stop the support of very old versions in JDT to reduce the complexity of internal code. Yeah, Jay Prakash has answered saying that no, not at the moment. Same answer, no, not at the moment. We plan to leave the support as it is. However, if the support will be there, but the priority will be given to the bugs in the later part of the in the later releases, for the later releases. I see Jorg commenting that it's interesting to see how different features connect each other. Yeah, so there are more interesting things that's going to come. Even the underscore is going to be part of the pattern instance of, and pattern matching, and we are going to have something like don't care, and you can skip some of the variables, and using the underscore, something very similar to Python, and all of them fit together. So I think it was well planned, starting from not allowing underscore initially and to this phase to something in the future. Okay, so one more question I see: do record constructor parameters always depend on order, or other? Do they do record constructor parameters always depend on order? Yes, they do. So you have to have the constructors in the same order as the record components, and if you have that, that is called a canonical constructor. And of course, you can have constructors which are different from the canonical constructors. In that case, that doesn't define a record. At the end, you will have to call a canonical constructor. A canonical constructor is a constructor which is a constructor which has the parameters the same as the record components, that is the record parameters. Thank you all. I think the time is up. Thanks very much. Thanks for joining me. Bye.